Now, I like these problems because you can get a little creative. Totally up to you the way you want to approach it. Some kids like to go ahead and write this as m to the 10th, n to the 5th, and they put the whole thing in parentheses with a 1/5 out front or up in the corner, which is totally fine. Other kids will write m to the 10th, n to the negative 5th, and then put the 1/5 out in the corner. It doesn't matter. You're going to get the same outcome either way. I'm just going to use this one because there's no negative exponents, so I know I won't have a final step to do. So we are going to distribute the 1/5 to all exponents. And this is a division problem, so you're allowed to distribute exponents in a division problem. So our top will now say m squared, and the bottom will be n to the first. And that's it, we're done. Can take the same approach for number 2. We can put all of this in parentheses and then put 1/8 outside. I, however, think it's going to be easier if we go ahead and simplify what's in here. So if you have n to the 18th over n squared, and then you have p to the 7th. I do not like negative exponents, so typically what I do is just move them right off the bat. So I'm going to move my p to the first upstairs. And now it's positive. So if I use my exponent rules, when you're dividing like bases, you can subtract their exponents. So my new problem is the 8th root of n to the 16th and p to the 8th, which is the exact same thing as n to the 16th, p to the 8th, all to the 1/8 power. And then we'll distribute that 1/8 in and get n squared p. Now number 3 has a plus sign in it, so we are going to have to be very careful. However, we can still work with simplifying our radicals. We can go ahead and try to get that condensed and organized a little bit better. So what I'll do is I'll change 16 into 2 to the 4th, w to the 10th, and it's all to the 1/4. And then I have 2w, and this is the same thing as w to the 6/4. Go ahead and I'll distribute my exponent, get 2 to the 1st. I will get 10 over 4, but I'm going to change that to 5/2. And while I'm at it, I'm going to change 6/4 into 3/2. Now one thing I can do is realize I am multiplying like bases, which means I can add their exponents. So I can actually make this 2w to the 5/2 power. I happen to notice, I have 2 groups of w to the 5/2 plus 2 more groups of w to the 5/2. So I can just make that 4 groups of w to the 5/2 power. So you can add the numbers in front as long as these items are the exact same, but they don't change. It's still w to the 5/2. Now the only thing wrong with this answer is we have an improper fraction, so we are going to want to fix that. So we'll change it to 4/2 and 1/2, which makes w squared root w. And I just want to bring down my 4, and then I'm done. Number 4, you have to be careful. I do see a multiplication sign, but we do not multiply the exponents. It's not like we have an exponent outside that we're distributing. All we do is simply add 1/2 and 1/4. So we will now have p to the 3/4 power minus, again, I'm going to change this into an exponent scenario. So we have 2 to the 4th, p to the 3rd, and it's all to the 1/4. We're going to distribute, so we get 2 to the 1st and p to the 3/4. So we actually do have some like terms. We have one group of p to the 3/4 minus 2 groups of p to the 3/4. So we're just going to do 1 minus 2 and get -1. And then we'll have p to the 3/4. And we can change that into -1 times the quartic root of p cubed. Now keep in mind, if you're looking at an answer key, they usually don't write the 1, they'll just write a negative. So as long as we realize that the 1 is there, it doesn't matter which way you present your answer, but this is how it would be presented on an answer key.